Hey team, what's up? Shadolance back with a video I haven't done in a very long time actually. I'm doing another Shadolance's Tactics Mathematics video. I did one of these about a year ago or so, did a whole bunch of cool stuff about what you can do with all the game mechanics and physics and stuff, so I wanted to do another one. Now if you remember from the first one, I used Microsoft Paint, and that's exactly what I'm going to be doing again. Last time I went over 3 topics, spread recovery, recoil, and damage drop-off. This time I'm going over 3 new ones, and I'm going to go over damage drop-off again, but in a little less detail. But same ideas, since a lot of you probably won't go back and watch the other one, and damage drop-off was probably the best part of it. So first off, I'm going to start with something new, cone-shaped spray. So this is something that's probably going to catch a lot of you by surprise. So first of all, you guys know you have your reticle. Let's say, oh, that's your reticle right there. Well, what I'm going to do is I'm going to draw it sideways. So change the perspective from your reticle like this, and you're looking at it straight on. So you're looking at it just right there in the center, and you're changing it to something like this. So I'm going to draw another one over here. So you're looking at it from, if I grab an arrow, you're looking at it that way. That's your reticle right there. So we're going to delete that arrow real fast, and let's say this. So you would expect your spread to look something like this, where if your gun is right here, you're firing and your bullets can go here, and you're expecting the wall to be right there, or whatever you're shooting at, whether it's a person or even just a blank spot in the air. That's what you would expect it to be. However, that's not entirely true, and part of the reason you can tell that's not true immediately is because whenever you move, like let's say, oh, for example, there is a wall, let's use a square for this, a wall right here, and I'm going to go ahead and delete this. That's not the select tool. I'm not very good with Microsoft Paint, so I'm doing this a little bit slowly. If here's a wall, and let's do it like this actually. We will say that the black part that I'm covering right here is a wall, and the white part is, actually we'll make it yellow, is a further wall. And let's just go ahead and say that, oh, we are aiming at the yellow part right now. So our reticle is right, now let's not use this, let's use a black color. Oh, that didn't work. Let's go ahead and grab the elliptical tool again. Let's say our reticle is right there. Well, if this is further back, we're going to call this, oh, I don't know, 15 feet. And we're going to call this one 30 feet, or whatever. So you have 2 different reticle areas. But if you aim at this wall, and then you aim at this wall over here, your reticle size doesn't change. It stays the same size. And realistically with a gun, that's not true. That doesn't happen. If this were to actually be true, this spread would, in theory, get a lot bigger. And if you were to draw them side by side, it would look something like this. You would have the black one would look like this, and the red one would look something like this. Oh, whoops. We want that to be black, and we want to grab the red one. And the red one would, actually we'd do it in yellow just so it looks like this, would look something like this. So your reticle would look something like that. It'd be really weird shaped. And that's obviously not true, because if this is further back, you're going to be hitting a lot more against the wall. So what I suggest you guys think about is that the reticle size is actually more like this. It looks a lot more realistically. If here is your reticle, actually let's make it black, is right there, and you are, let's say, whoops, let's make that black, and I really don't like paint for this one reason. Your gun is right there, and you would expect that your reticle size looks like that. Well, what I would actually suggest you think about is that if the wall is back here, your reticle size is more like this. It comes and draws like this, where it doesn't quite reach the tops and bottoms of your actual reticle size. So if this is your reticle, your bullets are going to be smaller than this. Now, if you want to test this, go shoot against a wall with a P90TR or such, and you'll see that your bullets go well within the spread reticle size, even though your spread reticle size is getting bigger. So what I think is that the reticle size is actually showing you what the spread is at the maximum distance of the gun, not the actual area where you're pointing it, which is kind of weird. Which is also true because when you fire outside of the range of your gun, if you use a TA-ACOG-1 scope, I do believe, it will show you the distance of your gun that it can shoot. And one other thing I'd like to point out with that is that despite people saying, oh, the G36E has longer range than the other assault rifle M416 or something, that's not true. All assault rifles have the same range in the entire game. SMGs are pretty close. They're a little bit less, but they're like that. Sniper rifles have a huge range that would go off this chart. Shotguns are pretty short. They're about right there-ish. Less than that even. It's more like this. Shotguns would be there in comparison. And pistols would be a little bit further. Pistols are about SMG range. That's about right. And yeah, it looks like that, and obviously, RPGs and such go on forever. But there's that whole thing there, so they look very, very different, which is another mess there. So I wanted to go over that first. Basically, your reticle lies, that's the spread at the maximum range, not wherever you're pointing it. As long as you are anything less than maximum range, your shots are going to go within your reticle, and if you're really close up, a P90TR's spread, any gun spread actually, is going to look more like, if this is your real reticle, it's going to look a lot more like your spread is something like this. I'm being dead serious. Most assault rifles will have that kind of accuracy at point blank range, not this. Which is why when you're spraying at full range, at like perfectly close range, and your reticle is huge, but you're not hitting any shots, it's because you are literally just off your mark. You're not aiming perfectly enough. And this is a big problem with a lot of sniper rifles. Your aim is so good that you actually can't hit. It's a reverse problem, takes some thinking about, but that's the first mess. The second mess is splash damage. This is to do with grenades and anything RPG, LAW, anything that makes an explosion. Now, I'm going to go over this in a very strange manner. You have to think about this in a three-dimensional shape. Now, there's a couple of things I'd like to point out first. A couple of things is one that you want to watch my physics fails that have come out already. You guys have probably already seen that by now. But go watch my top 11 physics fails and recall the one thing I said about grenade and explosion physics. If you are standing, say, let's grab a line here. If you are standing here, and a grenade is here, and what I was talking about in the video, your center of gravity, your center of mass, your center of person is, say, right here. It's below this, but you were standing somewhere down here. And the grenade explodes, say, oh, give me this red right here. This is a very pretty red. Explodes right here. The grenade explodes here, and the grenade itself was originally, oh, give me that pencil again. The grenade was right there. You're not going to be damaged even if your head or whatever is up here. You're not going to be damaged because your center of gravity is below this part right here. Your center of mass, whatever you want to call it, center of gravity, center of mass, I'm used to calling it center of gravity because of physics class, but it's below this right here, and that means that you're not going to be damaged by it even if you have other parts of your 3D model above here. So keep that in mind as I go ahead with splash damage. So splash damage, let's say you have two explosive grenades or whatever. You have the HE and you have the regular. I'm going to call the HE this light green, the regular grenade this light green, and the HE this yellow over here. So first of all, green, we're going to say your grenade explosion radius is that, actually we want to have a circle, don't we? Your grenade explosion radius is that big. Actually, let's go ahead and do it like this. And the HE grenade, nope, that is this. We want to grab a new color here. And the HE explosive grenade is that big. We're just going to say that just for giggles. You know, you get the idea. So if you're within this range, you have the possibility to take damage, which is the general idea of a grenade. So one thing I'd like to point out is that this radius for the green one, actually I'm going to do this in green, the radius for the, actually I'll do it in a lighter green, is right here. That's your radius for the green one. That was a terrible radius. I'm going to redraw that. There, that's a beautiful radius. So now if we come back and I grab myself another color yellow, and we're going to say that, I'm going to draw this slightly above this, this is your radius for this. Now what you guys need to know is that when you're within X amount of range, say you're within, oh, let me grab another circle here, and make it here. If you're within this range of the small grenade, you are going to die. Like, you are for sure going to die no matter what you're wearing. That's because it does over 100 damage, and explosive stuff completely ignores your AP. Doesn't matter how many armor points you have, you are going to die if you are right there. Doesn't matter how much tanking ability you have, that's where you are going to fatality, you are going to Mortal Kombat off the stage, and you guys get the idea. And, you know, the other one for the big grenade is going to be a little bit bigger, so if I wanted to draw that, grab myself another ellipse right here, and, oh, it might be, say, that big right there. It might be a little bit bigger. So now that we have multiple circles drawn and you guys are all very much confused, let's go ahead and get into the main point of this. So you have different radii here, and the whole point of this is that your radius is going to determine how much damage you take, how far you are from your grenade, or the grenade. It's probably not your grenade. I would really hope you don't blow yourself up on a regular basis. So my point is that let's say you take, I'm going to redraw one of these radiuses over here. And this is true of any grenade. You just have to pick the size that you care about and think about it in an exponential scale. You're going to notice that within, say, to here, which is this part right here, that you will die. You are going to die right there. Happy thoughts. Now, here, you might live. I'm going to go and pick a little darker green color. You are going, actually, I'll pick a lighter green. You are going to live right here. But you are just going to live barely. You're going to have maybe 5 HP. And now, but right next to it, Like, that's right here. But on the other hand, right here, you're going to survive, and you're going to have 30 HP or something like that. So you're wondering, well, wait a second, I'm not even double as far as this, but I already have way more HP. I have 6 times as much HP. Now, these figures are just for scale. They're not actually realistic. They'd probably be closer to about 20 or 15 or something. But the point is, you have more than double your HP left, but you have gone less than double the distance from the grenade, from the radius, the death point. So you're wondering, why did I not take more damage? The reason being is because the scale is exponential, which means that as you go down, or technically it's logarithmic, or whatever you want to call it, you are going to take a lot of damage. So if I were to draw this like a graph, if I remove this, and I draw this like a graph, where we have, the amount of damage you take, D right here, and the amount of distance you are, little d over here. So as the less it looks something like this. So you're going to take less damage the further you get from the grenade. If that makes sense to you guys, that's what it looks like. It's sort of an inverse exponent. It's the x equals greater than 1, or greater than 0 in this case. 1 is usually what you want to use, of 1 over x, that graph right there. That's what this looks like right here. So that's just a little idea of how grenade physics works, explosion physics. So the farther you are from the grenade, the less likely you are to be killed. But if you are within that one short death area, I'm going to redraw this right here real fast before we move on. So this is like a blown up version of it also. So if this is the death side, if this is the side that you die on, and this is the side that you, let's use green, live on, this little area is a very, very big point where right here you might take a ton of damage, and right here you might not take a whole lot, but right here you die. So you just need to be very, very careful when you're within the grenade's radius, and you need to learn pretty quickly, and not lying, it's a good way to practice, throw grenades at the ground and try to see what you can survive. So it really does help when you know your exact grenade's radius, because then you can figure out, is this a good hiding spot or not? And with that, I'm going to move on to the next topic, because that one took quite a while actually. Next up, we are going to take a look at damage drop-off again. Now, I'm going to draw this graphically and sort of leave it at that, because I went over it in pretty hard detail in the last episode about a year ago. So I highly suggest you guys go see that, since I do have the link in the description. Now, moving on, let's go ahead and draw our graph here. This is going to be a little bit boring, but I hope you guys will get the point pretty easily. I'm actually going to draw 2 graphs, and you'll see why in just a minute. So once again, we're going to have the damage you take. I'm going to call this change in x, which is going to be your distance. This is going to be your distance right here. This is your d. But I'm going to write this down here because it's easier, and 2 Ds is kind of hard to deal with, and as a guy, I really don't like having more than 1 D in the area, so if you get that drift. But continuing, we're going to make this fun. So let's say you have, we're going to call this a DSR-1 Tactical. Actually, we're just going to call this a sniper, a DSR, and we're going to call this an assault rifle. We're going to call this a, what has a low damage drop-off? An LR300ML, because this gun is awful. LR300. I don't know if there's a dash there, but I'm going to go with it. ML. Okay, so we have 2 guns here. We have an assault rifle with terrible damage drop-off, and a DSR with really good damage drop-off. The DSR series is well known for having good damage drop-off. So here's what I want you guys to look at. Damage drop-off is how much damage you're going to do per distance, similar to the grenade that we saw earlier. So a DSR, if we're going to call this 100 damage, we're going to call these 100 damage, so that you are going to die. We're going to assume that that is a one-shot kill. Well, first of all, the LR300ML doesn't have 100 damage. It's around 37 or something like that. I don't have the stat off the top of my head, but it's not very high. Now, DSR does have 100 damage. A 37 damage LR300ML, we would assume that you would never do more than 37. That would be at a 100 HP and 100 AP medium vester to the chest, if I am correct. So a 37 damage, a perfect 37 damage would look something like this, where you would always do 37 damage no matter how far away they were from you, but we know that's not how combat arms works. First of all, it doesn't usually quite do 37 damage. It usually does a little bit below that because combat arms stats lie like terrible, so it's just really bad. The way it really looks, a good damage drop-off for a gun would look something like this, where you go really, really far, and the damage drop-off is just in the last bit of effective range. By the way, we're going to assume that this line right here represents the maximum effective range of the gun, that past that, the bullet disappears for some reason and does no damage because combat arms physics makes so much sense. But anyway, this would be a good damage drop-off. Now, sadly, this gun has awful damage drop-off. I'm going to show you what the worst damage drop-off in the game looks like. May or may not be representative of this gun, but it is pretty bad, so you guys will get the idea, I hope, because I'm pretty sure you guys are a lot smarter than I am. So a bad damage drop-off would look something like this, where it would just go down and down and down and down and down and down, something like that. Where it would do really, really bad damage the entire way, or it would look something like this. something more, exponential like that, or reverse exponential, inverse exponential, or whatever you want to call it. Now, the DSR is very well known for having good damage drop-off. The DSR Tactical is actually the best for damage drop-off, not the Andromalius. I'll draw out both of them so you can get an idea of what they look like. The DSR regular looks something like this. It goes down like that, so it's a fairly good damage drop-off. Not bad at all. You should still be doing quite a bit of damage. If we say this is the maximum effective range, that was a little bit off scale, but it should be going from about here to about here. So you should be seeing something, around 80 damage. I'm just calling it 80 damage. I know it's not really representative of that, but you guys get the idea. And we're just going to draw a line here to make it 50, so that's 50 and 50. 50 and 50. I like numbers. Okay, 50. Cool. Whereas the DSR Tactical is something more like this. It's literally almost perfect damage at maximum range. The Andromalius, I'm going to draw this in red now, if you let me whip out my very red color. The Andromalius is very, very good. It's very similar, but it does tend to drop off faster at the end, slightly more like that, so you're less likely to get that one-shot kill. However, it does have faster spread recovery, and if you watch the last episode, you will see why that is actually one of the reasons the gun is better than the DSR Tactical. So that's just one thing I'd like to point out there. Now, going back to the black color over on the LR300ML, the LR300ML looks something more like, if you're down to the 37 here, looks something more like that. It's pretty bad. At maximum range, you'll barely be doing 10 damage. It's pretty pathetic. It's really bad, and that's just one of the guns that we don't usually like. Now, if we come up to a G36E, a G36 has around 45 damage, so it's going to start around here, and it usually drops off to about right there. You really shouldn't be doing any less than about 35 damage at most ranges, maybe 25, somewhere in there, depending on if you're shooting at a tanker or where you hit them. But I'm assuming that you're hitting a medium vester in the chest. You should be doing somewhere between 35 and 25 damage. This is before you take armor points into consideration, so that's why the gun would typically do, around 25 damage to 30 damage to a medium vester with full armor points. This is before you take armor points into consideration, so that's a different story entirely. But if you were to take armor points into consideration, you would just have to lower the curve a bit. So if this is the original, the lowered curve would look something like this. If you take armor points into consideration, it will be exactly the same shape, lowered by the same ratio of armor points you have out of 100. So let's say you have X armor points out of 100 total. That's the ratio to what your damage will do. So normally, let's say you did 35 damage out of 100 possible, because he has 100 HP. Armor points you're going to consider, you might do, that ratio is going to lower this ratio by the same amount. So you would multiply this ratio by this ratio, and that would be your total final damage. That's part of the way the equation works. It's a little more complex than that, but I think you guys get the idea. I go into this in more detail in my previous video, if you can believe that. If you're interested in that, do go check it out. The link is in the description below. But the last thing I want to go over is also my shortest thing, sound physics. Now, this is really, really strange and does defy all ideas and ways sound are supposed to work. Now, first thing I want to clear up before I really get started is that Whisperer really just does this. If you have, say, normal this kind of a sound range, this is the range to which people will hear you. All Whisperer does is make your sound range something more like this. Something more like that. That's all it does. It slightly lowers it, and that's about it. However, it also lowers the decibel a bit, so if you raise your decibel on your sound machine, your headphones or whatever, you will be able to hear people using Whisperer at a slightly larger range than you typically should be able to with just regular headphones without any boosting. So that's why I run my audio on very, very high bass. So if that really helps you guys, you should try doing that. Turning up the bass always helps. Drop the bass. And anyway, so the next thing we want to do is show you guys how the actual sound physics work. Now, this defies all sources of physics. So what I'm going to do is I'm going to take that circle I drew, pretend this was the big circle I had here a second ago, and I'm going to rotate, whoops, didn't mean to do that. I am going to rotate it just a bit. So now you're going to be looking at it on a three-dimensional plane. Now, here's the reason why Combat Arms physics is awful. So if I'm going to draw this, I'm going to draw Whisperer real fast one more time, right there. Well, the way that Combat Arms physics works is the closer you get, once again, it is an exponential function, just like the previous thing that we saw with the damage drop-off and the splash damage. The closer you go in, the louder you will hear it. the closer you get to the center, which is right here. That's true of no matter what kind of sound function you're listening to. I'm going to change the color of that because I'm going to keep using this picture. So that is how that's going to work. It's really strange. A lot of people don't like it. I personally don't mind it, but that's the way it typically works. So that's that. The thing that does not make any sense about Comet Arms logic is that no matter how high above them or how low below them you are, you hear them at the same depth as long as you're within the same range. So the only thing that actually affects how loud you can hear someone is how far you are from them on the x-axis. If we call this the x-axis and this the y-axis, if we call this x and we call this y. No matter how far from them on the y-axis you are, then it doesn't matter. You can be as far from them as you want. You can be 10 miles like that up, and you can still hear them as long as you're within X range. Now, if your X range is too far, then you won't hear them. Obviously, if you go across the map on Kill Creek, you won't be hearing someone on the opposite side. Now, to clear up something else, I'm going to go ahead and erase this really fast. If you have Whisperer and you have Awareness, what Awareness does is it raises the higher pitch decibels that you have. So right here, once again, let's go ahead and draw this like this. We have our regular sound range, and we have our, and we have our Whisperer sound range right here, which I'm going to change to this color. And now I'm going to show you Awareness using yellow. If this is Awareness, this lets you hear other people. Now what Awareness does is it lowers your bass decibel. It lowers your pitch decibel, so you would want to turn up your bass. However, what Awareness does is it raises your pitch decibel as you go out. So if I go ahead and grab this, and let's go ahead and do this. Let's do this in green. As you raise your pitch decibel, and I need this thing, as you raise your pitch decibel, you want to turn up your volume. Now, using dark green, if we go inward, you don't need to raise your volume necessarily, but you want to raise your bass. Because if you just raise your bass, you're going to be hearing all the lower tone decibels that come into this area right here that it turns it down to. What it doesn't do is necessarily, it doesn't turn down your volume. It does turn down the volume by a little bit, but what it really does is it changes your frequency. And this also. So if you're working to use your Awareness ability, what you want to do is turn your volume up, not necessarily your bass. But if you're trying to play the game maybe in a competitive clan war and you want sound horror, you want to turn up your bass, not necessarily your volume. Now you may want to turn up your volume too, that's a preference, but bass is what you really want to turn up to hear those Whisperers and other people walking slowly. That's what I'm going to conclude this video with, guys. I hope you enjoyed mathematics of Comet Arms a little bit. Please go check out the other video in the description below. I'm sorry this took so long, but the previous video just once again has spread recovery, recoil, and a much more in-depth damage drop-off. Hope you guys enjoyed this video, and I will see you guys in the next one. Shadolance out.